Welcome back to the channel. In this lesson, we'll see how to locate a point using both the Cartesian and polar coordinates. At the end of this lesson, you'll be able to convert from the Cartesian coordinate to the polar coordinate and vice versa. That said, let's get into class. In two-dimensional planes, the position of any point can be located using either the Cartesian coordinate or use a polar coordinate. Now, in the Cartesian coordinate, we're putting it under the x and the y axis. That is, I have my y axis and I have my x axis. Now, if I have to locate a point in the Cartesian coordinate, all I need to pick is to pick here. If here is the point, then I'll be picking the x value to locate the point. If this is x1, then I'll pick the y value to locate the point so that this is y1. So I can locate this point with x1 and y1. Now, if I have to locate this point with the polar coordinate, I want to assume that if I have a circle that probably passes through this way, so I permit my diagram, this circle obviously has a radius. So the radius, we call this radius r. Now I can locate this point by the length of this radii and also by the angle at which this radius theta makes with the x-axis. So I'll be locating this point with r and theta. While this is the Cartesian coordinate, here I'm using the Cartesian coordinate. Here I am using the polar coordinate. Now the good thing is we can convert from the Cartesian coordinate to the polar coordinate and from the polar coordinate to the Cartesian coordinate. Now, if you look at my diagram carefully, you see that across this point to this point, I obviously have a right angle triangle. Let's draw that out. So that here is my theta, here is my r, here is my y1, and obviously here is my x1. Now, if I'm given y1 and x1, and I'm looking for r, from Pythagoras theorem, we know that r squared will be equals to y1 squared plus x1 squared. So that r now will be the same thing as the square root of y1 squared plus x1 squared. And at the same time, my theta will come from SOHCAHTOA will come from the tan inverse of y1 over x1. Let's take an example. Our example says that we should express in polar coordinates position 5 and 2. Obviously, this is my x value and here is my y value. So if I'm to draw this on my Cartesian coordinate, this is my y and here is my x. For my x, I'll have this as 5, and for my y, I can have this as 2. So that I can trace my point this way. Here is the point. This is the point at 5 and 2. So that here is a radii. I can now draw this here. Here is my r, and here will be my what? My theta. So that my r now will come from the square root of 5 squared plus 2 squared. That will be the same thing as the square root of 25 plus 4, which will come from the square root of 29. So that r obviously is the same thing as 5.38. And my theta also will come from the tan inverse of 2 over 5, which is the same thing as the tan inverse of 2 divided by 5. That's the tan inverse of 0.4. So that my theta will be the same thing as equals to 21.8 in degrees. Now, if my theta is 21.8, that means I can easily write my 5 and 2 to be the same thing as 5.38 and 28.8 in degrees. Is where the point lies in the first quadrant. There are other quadrants we can consider. See them. Now, once again, here is the Cartesian coordinate. Here is my first quadrant. Here is my first quadrant. Here is my second quadrant. Here is my third quadrant. And here is my fourth quadrant. My angle can lie in any of these quadrants. If my angle lies in the second quadrant, that is, I'll have my point move this way. For example, then here will be theta. If my angle lies in the third quadrant, then we'll have my point this way. Probably my point is somewhere around here. So that here then I'll have this to be theta. And for the fourth quadrant, here's the fourth quadrant. If my angle lies here, and adventure I have it this way, then I have it move all this way so that here will be my what? My theta. Let's consider each of them. Here's an example for us for the second quadrant. Now, I've been told that I have it, here is y axis and here is my x axis. Now my point is at minus 5 and 2. So that if you trace your minus 5 on the negative side of the x-axis, you have it this way. So that here is my angle. Now, but uniquely, if you look at it, the value of from here to this point and from here to this point are both equal, is 2. So this is 2. And here is my 5. And I still have my angle in between this way, that's theta. Same values we got for r. Remember, we got r to be equals to the square root of 5 squared plus 2 squared, and r will still be the same thing as 5.38. 5.38. And here is theta once again. Theta once again will be the same thing as the tan inverse, because we're using similar values to what we used, of 2 over 5. So that theta will be the same thing as the tan inverse of 0.4. Theta, or that's the angle in here, or rather, let me refer to this angle as alpha. Let me call this alpha. So this is alpha, because we've used theta here so that we don't get confused. The tan inverse of 0.4, like we calculated the other time, is 28.8. Alpha will be the same thing as 28.8. But while alpha is 28.8, total angle on a straight line is 180. So that theta now will be the same thing as 180 minus alpha, which is the same thing as 180 minus 28.8 minus 21. Sorry, it's minus 21.8. 180 minus 21.8. So that theta in this case, because it's in the second quadrant, will be the same thing as 158.2 degrees. Now, if my angle lies in the third quadrant, let's see the third quadrant. In the third quadrant, our example says we have x to be minus 2, and we have y to be minus 3. So if I have my point adventure here, so we have it this way. That means here is my theta. But here, I can have my beta here. Let's call this beta. So that here is my r. From here to here, obviously, is same thing as from here to here, which is 2. And here to here is also 3. So that r obviously is equals to the square root of 2 squared plus 3 squared. R will be the same thing as the square root of 4 plus 9, which is equals to the square root of 13. R is the same thing as square root of 13, 3.61. 3.61. Now, if R is 3.61, beta is the same thing as the tan inverse. This time around, beta will be the tan inverse of 2 over 3. As the x now over the y. That will be 2 over 3. That will be equals to the tan inverse of 0.667, which is the same thing as, so beta is the same thing as 33.7 degrees. Now, theta will be the same thing as 270 minus beta, which is equals to 270 minus 33.7 degrees, which is the same thing as 236.3 degrees. 236.3 degrees. I'd like you to take this as an example. Here is in the fourth quadrant. I'll be glad you try your hands on this and share your results with us in the comment section. Thank you for staying with us, and see you in our next class.